All right, so if we want to do variance and standard deviation, this is not going to be too much different than things that we've done in the past as well. So the variance and standard deviation provide a measure of spread for the variable distribution of a random variable. So the variance of a discrete random variable is just going to be, once we find that mean, each discrete variable minus the mean squared times its probability, and then we do a summation. Or equivalently, and it's easier to do by hand, it works out that this is just simply going to be your x squared times p summed up, and then you subtract your mean squared. Standard deviation is a discrete random variable. A discrete random variable is just going to be, once again, the square root of your variation or variance. So we're going to do this in a calculator again, because that will be a lot easier than trying to do this by hand. Okay, so we're going to use this example right here. So we have these values and we have these probabilities. And we see what we should get at the bottom. So you have that as a comparison to make sure that we are getting the correct numbers. And notice it's only going to give you population this time, or it may, we'll see. So what we're going to do is we go to second list. Oops, sorry, that's not where we go. We go to just list and we go to edit. So your first list is going to be your random variable. So we had random variables of 1 or 0, 1, 2, and 3. Then our second list are those probabilities. So one had a probability of 0.2, then we had a 0.5, and we had a 0.2 again, and we had a 0.1. All right, so second quick to get to the screen here, just to make sure that your screen is clear before we go back to statistics, and we go to one variable statistics. So list 1 is where you're going to put your discrete random variables. Your frequency list, or list 2, depending what your calculator says, that's where you put your second list. So just something I noticed that some people are bringing in calculators. Sometimes they say S list, X list, and Y list. But what they're really just saying is that your first list and then your frequency list. So if you see it like that, it's the same thing. Okay, then we hit enter and calculate. I think one of my values is off because I did not get the same thing. I'll go back and check. Yeah, one of my probabilities was off. Last time when we were doing this, so we did this by hand for the mean, we still see we're going to get this 1.2 here. We can do your mean this way as well. And then we see here your standard deviation. Okay. So not only can we avoid doing a mean by hand, but we can avoid doing standard deviation and variance by hand. So we already found this mean earlier. We know that our standard deviation, and it's only giving me the population one, but that's okay. That is going to be make sure I got the right symbols in here. And if we try doubling that, that's going to give us our variance. 87177. So if you were struggling trying to get these in and they were not working, try to use as many numbers as possible. Yeah, that sounds more like what it should have been. Try to use all the numbers in here before you square it to get that variance. So if you're struggling with homework questions, that maybe the problem is you just need to have more decimal places when you square. So there we go, mean, standard deviation, variance. Okay, so we're bringing back this data again. So this was the population of 5,000 undergraduates at a certain university and how many courses they were taking. We had the probabilities. So here we want to figure out what the mean number of classes taken and what is the standard deviation for the number of classes taken. All right, so let's clear out my screen here. So go to stats, go to edit. So remember, if you clear out the list, go to the top, hit clear, enter. You don't always have to clear the list. You could also just enter in each value right on top of everything, and it'll just cover what was behind it. So we put in my variables and then their probabilities. Oops. Well, go back one, cover that up. And then we have 0.33 or 1136, 0.3728, 0.2714, and 0.0176. Okay, so just make sure it's lined up at the bottom so we didn't make a mistake. So like I said, I'm just doing second quit or second mode just to make sure that there isn't anything on the screen that's going to interfere when I try to do this. Then I go back to stats, go to calculate one of our statistics. So list, first one is list one, the second should be list two, and we go to calculate. So we see that the average number of classes on average, they're taking 3.6482 classes in a semester. And then the standard deviation is actually 1.3069. So let's just round these. So if we want to figure out the z-score, for taking 7 classes, so maybe in the future someone takes 7 classes and we wanted a z-score for that, we could find that here. But just as a reminder, because we're going to use z-scores again, z-scores are just your variable minus, it is your variable minus your mean divided by your standard deviation. So I'd have 7 minus 3.65 divided by 1.31. So don't forget to put parentheses around the top. And I'm going to get a z-score of 2.56. So just as another reminder, when we were trying to decide if something was abnormal or not, we said anything that was over 2 standard deviations or a z-score of 2 is abnormal. So it's unusual to take 7 classes. Like I said, just kind of a little bit of a quick review there because we're going to come back to these topics not too far into the future.